Alright guys, welcome to another video on linked list. Today we're doing problem 141, linked list cycle. I do recommend you guys understanding the solution to finding the middle of a linked list because this will help us with this problem. So with this problem, the description reads, given head of a linked list, determine if the linked list has a cycle in it. There is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, POS, which I think stands for position, is used to denote the index of the node that the tail's next pointer is connected to. Note that position is not passed as a parameter. So if we see our function here, has cycle, that's given by LeetCode, there is no parameter for our position, okay? That's just something that is done internally, as I mentioned here. Return true if there is a cycle in the linked list, otherwise return false. So they give us one example here, right, where position is 1. So this position at the first index here, this node can be reached by the tail's next pointer, which we can see here, right? -4, its next pointer points to index 1, which node would be 2. Okay, so in this case, we return true. Now, I guess the question is, how would we solve this problem? Okay, of course, as I mentioned, you want to have knowledge of finding the middle of a linked list. And why would that be useful here? Well, that would be useful here because we know that the middle of a linked list for, let's say, 5 elements, or yeah, let's just say 5 elements here that I'm going to draw out for you guys, will look like this, right? We said that we're going to have, for the middle of a linked list, we have 2 pointers, right? We have fast and slow, okay? Or after each iteration, at the end of this, right, of course, we first start off with slow and fast here, but we know that after some work, right, slow would end up here and fast will be here. And we could return this because this next pointer is none, right? The tail of a linked list pointer is always none, so we can return this, okay? However, we know that in our problem, right, if we look back here, let's just do the case of 4 nodes. We know that if we have these 4 nodes, this next pointer is no longer none, but in the problem, they pointed back at this node, okay? I'll just put these nodes as 1, 2, 3, 4. Sorry for my chicken scratch handwriting. Really hard to write with a mouse. How can we use this implementation of finding the middle of a linked list for finding if a linked list has a cycle? Well, we can just keep iterating and keep using the same algorithm by moving our fast pointer twice as fast as slow, and eventually they will meet. Now, why is that true? If we think of this in terms of something that we might, have done in high school class or even middle school, anything like that, we can picture a track, right? And say we have 2 runners, right? Runner 1 and runner 2. They both start at the same position, right? They both start at the start line, okay? And you're running this track, this closed loop track, let's say for 30 minutes. If one runner is faster than the second runner, which is normally true in many cases, both of the runners will meet again some point in the track, whether it be here, here, or here. Does that kind of make sense? And that is similar to what we have here. We have a closed loop here, right? Where eventually the slow and the fast pointers are going to meet together. Okay? And all we have to do is return whether there is a cycle. We don't have to return where the node is, right? That's a little bit of a difficult problem, which we'll cover in another video. All we have to do is just return if there's a cycle, right? So in our while condition, right, we're going to have a check. Okay? The algorithm is going to have a check to check whether the 2 pointers are at the same position. If they are, we just return true. If we end up breaking our loop conditions, meaning if we have a linked list like this, right, where there is no cycle, well, how would we know that there is no cycle? Well, we know that the next pointer of fast is going to be none. And if that happens, we're at the end of the list. It's a list without a cycle. Okay? Now, the time complexity for this, of course, is going to be O of n again, similar to what we had for the middle of a linked list, right? We're going through the list one time, okay? On the worst case, on the fast case, we can find the cycle immediately, right? With like an extreme test case. And for the space complexity, again, we're only using 2 variables to store our positions, which is our slow and our fast pointer. So I guess what we can do is write the algorithm here, right? Of course, this is me assuming that you guys already understand how to find the middle of a linked list, so I don't have to go too much in depth into that problem. And that problem is very simple as well. So if you haven't done that problem before, I recommend taking a look at it, 15, 20 minutes, watch a couple videos, watch my video, and hopefully it helps. Here's our algorithm, right? First, of course, one of the cases you always want to check is check if list is empty. Right? If it is, what do we return? We return false. Okay, because we return the Boolean value here. Okay, so if the list is empty, of course it has no cycle, we return false. The next step in our algorithm is to assign fast and slow to head. Okay, and then we have a while loop, right? Now, what are the conditions here? The conditions are going to be the same exact thing as the middle of a linked list, right? While fast is true and fast.next is true. Now, inside this while loop, we're going to check if, right, slow pointer and fast are at same position. If so, return true. If not, if they're not at the same position, what are we going to do? We're actually going to just move slow and move fast, right? If we get to the, if we end up breaking this loop, right, meaning that the list is not empty, we assign fast and slow, and we're in this while loop. And if fast isn't true or fast.next is not true, the loop will break. What do we return in that case? We just return false, right? Because that means that we're at this test case here, where our fast pointer, the fast.next is none, okay? Meaning we're at the end of the list. That while this while loop will break, so we return false, there is no cycle, okay? Let's go ahead and get to the code. So if head is none, return false, okay? Slow equals fast, which equals ahead. While fast and fast.next is true, we're going to now check if slow and fast are the same position. However, looking back at this, there is an issue here. What's the issue here? Is if we check, if we have this if statement, if slow is equal to fast, return true. If we have this condition, we're going to actually have some errors. We're going to have an error with this problem here. If we check if slow and fast are at the same position, we're going to return true here for this problem, but we know that it's none. We know that this is false because there is no cycle. But we don't want to check on the first iteration of moving slow and fast, right? You don't want to check if the runners are at the same position at the start line, like right before the race starts, because they're always going to be at the same position. You want to check after the race starts. So in this case, let me cut this out and paste this here. This is where you want to check. You want to check after you move slow and fast, okay? So after I move slow, one position, and I move fast, twice as fast, then I check if slow is equal to fast. If so, I return true. If the loop breaks, we know to return false. Okay? That's it for this problem. Thank you guys for watching. Let's run this. Everything works. Okay, and submit this. I will see you guys on the next video. Thank you so much. Have a great day.